Our next session will continue on in the science field, and the title is On the Cusp, the Promise of Breakthrough Brain Research. And it's a session which is going to take us into the emergent applications of artificial intelligence and neuroprosthetics, and the sciences behind that. Our session leader is Maria Cattaui. She is the former Secretary General of the International Chamber of Commerce, and she's a member of the Women's Forum Program Committee. So I leave you in the good hands of Maria. Thank you very much.
So thank you very much, Jillian. I'd like to call to the stage Dr. Joanna Bryson and Professor Stéphanie Lacour. I'm getting the mic. So come and sit wherever you want. Oh. But it would be nice to have two microphones.
They're on the way.
Super. So in the meantime, what I'll do is just briefly introduce our two scientists, female scientists. So Professor Dr. Stéphanie Lacour is the Bertarelli Foundation Chair in Neuroprosthetics, which we will get to understand in a minute, in its technology at the Swiss Federal Polytechnic in Lausanne. Stéphanie is the recipient of many awards. She is also, her research is devoted to advance our fundamental concepts in man-made electronic systems that interface with the human body and particularly with the nervous system. Dr. Joanna Bryson is reader and head of the Intelligent Systems Research Group at the University of Bath in the UK. At first I thought these were systems that were intelligent, but it's a little bit more than that. Joanna's background is very interesting. She's an interdisciplinary researcher on the origin, structure, and construction of human and animal-like intelligence. She has degrees in behavioral science. She holds other degrees in artificial intelligence, in psychology. She has a PhD in artificial intelligence from MIT. She came to the University of Bath from Harvard's Department of Psychology, actually. And she has industrial AI experience, including for Lego, which really fascinated me, what you were doing with Lego and artificial intelligence. Might say something about Lego. And she is now the research leader for the Intelligent Systems Group and Artificial Models of Natural Intelligence. I thought we'd begin with you, Stéphanie, because I'm intrigued by what really is the field of neuroprosthetics. What is it about, and could you perhaps just give us one or two examples of what it is?
Okay, so in neuroprosthetic, there's two words, there's neuro and prosthetic. And so first, let me give you an example for what a prosthesis is. And this is something mankind has been fascinated with from the beginning, basically. We've been always trying to replace or repair part of the body that have been injured. So prosthesis would be a device or a structure that we man-made in order to replace something that has been failing in the body. And so a neuroprosthesis would be something that we will try, a device we will use to try and repair the damaged nervous system.
Give us an example of that kind of prosthetic.
So the most widely used today neuroprosthesis is a cochlear implant, and this is an hearing replacement system. And you may know someone, there's 300,000 people today wearing a cochlear implant across the world, and this is a system where we replace damaged function from the natural cells which encode the sound into neural information by using little electrical impulse that we place directly at the cochlea, which is the input of your hearing channel. And so the neuroprosthesis is really there to replace what has been damaged, and the cochlear implant is one of allows the patient to hear again.
Are there other examples that are very common that we know about?
So another example is what is called deep brain stimulation, and this is used very much in the context of Parkinson in order to remove most of the tremor that are associated with Parkinson. So the prosthesis there is an electrode that is implanted in the deep brain, so in the profound part of the brain, and by delivering electrical impulse, you can cancel the tremor associated with a Parkinson.
Now, both of those are very well-known developments, but you maintain that there is an impeding factor in all of this. I think you call it something very funny. What is it, the nail in the jello?
So the nail in the jello? Yeah.
Tell us about that.
So today, a lot of the material that we have access to or that we've been using either at the clinic or even in research lab to make those neural implants are based with material that are not similar to the brain. And so the material we use are very rigid, very stiff. So they're very good electrical conductors to deliver the electrical pulses, but mechanically they're very hard. And if you look at the brain, this is something that resembles jello or jam. And so if you imagine an electrode that is implanted today in the brain, it's really like a nail into jello. And the brain is not only soft, but it's also a dynamic structure. And so when we move around and when the brain moves just by simple pulsation of the blood flow, then you have constant motion at the interface between your implant and the brain. And this causes damage over time or bad performance of the device over time.
So the device itself, until today, which you call the nail, is an impeding factor. What are you working on? Are you working on devices that would not be hardwired, so to speak, that are not metal?
So there are many challenges with neuroprosthesis, but the particular take we have in my lab is to explore how we can change the materials we're using to make those very implants, and in particular use material that are as soft as the nervous tissue.
And so just to ask you an unfair question, and I will ask you one too like this. Good. So what is the promise? What do you think? What would be the future? What would you like to see in the research that you do? What would you like to see as a result, and what would it help?
So there are many neurological disease that are not taken care of today, that we don't know how to treat, where medication is not the solution. And therefore, combining traditional medication with other means of interfering with the nervous system is probably one of the solutions to help provide new treatment for neurodegenerative diseases and also trauma. So what I hope is that the research we do, and this of course is not a single person work, we have, this is a field of research where we have to work hand in hand. So I'm an electrical engineer by training, but I work every day with neuroscientists, biologists, but also the medical field. So I also work with medical doctors in order to better understand what are the challenges and what are the diseases we want to treat.
So you maintain that eventually this is aimed towards repairing neurological damage, spinal and brain damage and things of this kind.
Exactly. So
as soon as you go beyond the nail.
Exactly. So we're working today on a project where, in collaboration with another lab at EPFL, we've developed a soft implant for the spinal cord to help restore locomotion after spinal cord injury. So this is the type of project we're aiming for.
I forgot to say the EPFL is the Swiss Polytechnic located in Lausanne. So we'll come back and see if there's some questions on that, but I'll turn first to you, Joanna. Artificial intelligence. You say the word and everyone groans, you know, exactly what you're talking about. So what is the state of the field? And why do you maintain that the research into artificial intelligence is actually a way to better understand natural intelligence?
All right. Thank you. And yes, thank you to the sound person too. The state of the field is just exploding, as I think everybody knows. What people haven't entirely realized is that there's been artificial intelligence around for decades. There's artificial intelligence in your phone. There's artificial intelligence underlying Google. I don't want to, when I say artificial intelligence in the phone, not just Siri, right? It's part of the reason you take much better pictures with an iPhone than with just like an old-fashioned camera. It's not that you've gotten better, I'm sorry to tell you. It's that that AI is infused in all kinds of technology we have. People think artificial intelligence isn't here or may never come here because they over-identify with it. Now it goes back to my psychology background, right? But we expect anything that's intelligent is like a human because In the past, intelligence is how we differentiated ourselves from animals. But now there's something that's out the other side that can do calculus or arithmetic, and maybe we're getting pretty good at language now too. Maybe it can do all these things better than us. But it's not an animal. It's not like us. It's not an ape. It's not trying to compete with us for the world. It's a tool that we use. I love that I'm on with a prosthetic expert because I like to sometimes try to make artificial intelligence less threatening by calling it prosthetic intelligence. But it's not just a prosthetic for the individuals, it's also a prosthetic for corporations. So corporations are more intelligent, and this goes back to that wonderful talk by, I've forgotten her title, Ms. Shute, corporations can now predict us better, governments can now predict us better, because that's what brains are for. Brains process sensory information and then create predictions so that we can act. And the AI isn't necessarily going to act, but it can do that section of the part.
You know that there are also fears
Yes.
about the development of artificial intelligence. And we've seen lately, again in Switzerland, I'm doing a little bit of promotion for Switzerland here. We've seen the reviews of the possible breakthroughs in the Blue Brain project and so on. And scientists have written recently a letter, including Stephen Hawking, I think, signed the thing, saying that, wait a minute, we shouldn't go too far in developing artificial intelligence, because if we come to the end product, it will be the demise, he says, and that's the fear of humanity. So what do you say to all those fears?
Well, Stephen Hawking made that, started writing letters about this right about the same time that Cambridge created the Center for Existential Threat, which was, of course, in competition with Oxford's Future of Humanity Institute, both of which get money from philanthropy. I think the only scientific discipline that has created possibly an existential threat is, of course, physics with nuclear power, but not power, of course, nuclear bombs. But even that, there was this common stat about, 10% of weapons go off and there's no life left on the planet. I mean, it would obviously be a horrible thing.
That's not quite the same as artificial intelligence taking over.
No, it's nothing like artificial intelligence taking over. I think the closest to an honest threat was Nick Bostrom talking about the superintelligence. So he says that if something can learn to learn, then it would just explode and do things we can't predict. But that's what we already have. So I'm a computer scientist. My PhD is computer science, right? Computation, whether it's done by nature or whether it's done by a machine, is basically the same kind of thing. And the threats that Nick Bostrom describes actually describes how we're taking over the planet. Nobody made the decision that there should be no more wild animals, but there's almost no wild animals left. So side effects of intelligence are something that's deeply human. And artificial intelligence might help us to get smarter fast enough to become more mindful of what we're doing and actually find a way to control our future.
So, Joanna and Stéphanie, I'm going to go in a minute to all of you for some questions. Before I do, I'd just like to touch on something that's outside of your fields, but you have an influence on it, and that's the future of work.
Oh, yeah.
The future of what humans are any good for.
Right.
Right now, what you call the current, I call it computational intelligence, not entirely artificial, but computational that we're making, beginning to do so many tasks, so much. I mean, many traders and commodities don't trade anymore. They supervise the guys who are writing the algorithms that are doing the trades. Architectural plans, we're very happy that bridges and buildings are built by computational intelligence. You know, it makes for a solid bridge. This makes us feel very good. Doctors don't analyze many of the images anymore. They have computational intelligence. We're very happy about that. If a doctor can take 1 million examples out there and conclusion on you. But it does bring into question eventually,
what are humans for?
Yeah.
This is the real existential threat of artificial intelligence. It's not the existential threat like, will it wipe out humanity? It's the existential threat in the French sense, in the philosophical sense, of what are we for? And so I think actually all this technology is bringing back in the obvious need for the humanities, because that's a normative question. That's not something discoverable by science. That's something that we have to decide as a society. What are people for?
So here's my unfair question before I turn to the audience, to all of you out there. Unfair question. When are we going to have the ability, or are we ever going to have the ability, to actually create an artificial brain, an artificial intelligence that goes along with the brain, not just the pieces, not just the wiring, soft wiring, yes.
I actually have a line that is that it's not that we can't necessarily make real artificial intelligence something that's like a human. It's that it would be wrong to do so. We're obliged to make intelligence we're not obliged to. I don't think it's right for us to create and therefore own something that's just like a human.
You may not think so, but it may happen.
It's possible, but I would expect you would get that way through clones first. Even if you entirely replicated exactly a brain, it would be no use without the body. Our intelligence is, all the brain is wired into, this is what we were just hearing about, all the brain is wired into our muscles and our bones and what we see and what we hear. Actually, I was going to ask you about, can I do this?
No, yeah, of course.
Okay, that I was going to ask you, do people, because this is a big thing in artificial intelligence, but it could be equally in prosthetic intelligence, or prosthetics. What about super hearing? What do people say? I wanted the bionic man, the super strength, the super hearing, the super vision.
So I think here we're hitting indeed the two type of patient. Those who just want to be coming back to their initial position, but we do whenever we talk with people, a small fraction, I have to say, is asking for superpowers. And so it's true that there's a risk. To me, it's a risk to enhance capabilities of humans. But then it will be up to the society to norm regulation to actually control what we can do with this technology.
Actually, it's a very, very important question that's been raised many times, but more with biological scientists, which is that a world which has two kinds of humans, enhanced humans and those who can't afford to be enhanced. And just in case we don't think we're getting there, many of the nutritional additives that we use and a lot of the medicine already allows a certain portion of humanity to have some kind of enhancement. So this is going to be a major, and it takes in your sciences, but others as well, some of the biological ones too. Go ahead, Joanna.
This comes back to your question about machines taking over jobs. Again, the machines are not the motive actors. So what's really happening, I think now, is that we can, because the communication, this is what we heard yesterday too, communication is the main thing we've increased. So the rate at which we can recognize and communicate the best solution means that a very few people are getting all the money. And so you don't need lots of workers exploring anymore, one worker that can be replicated as a robot. So I think that in some ways it's wonderful. Artificial intelligence lets everybody see through Google, everybody can go and find these papers. With sufficient education, maybe they can even understand them. But it's also this, it's also creating this, or helping society to create this.
And it will, and I think it will have a profound effect on the concept of work and the concept of jobs, which many, as you know, identity is very often through your work. Yeah. And that will change the kind of thing. So I thought it's a very wide-ranging implications for these scientists and their work. So please feel free to ask any question that ranges not scientifically, but also into the philosophical and work. So we'll start over here.
Hi, you compare...
Can you introduce yourself, just
sure,
your name?
Sylvie Ouziel from Allianz. You compared artificial intelligence and human intelligence very much, and you probably have seen the latest advertising from IBM when Watson is chatting with Bob Dylan, showing artificial intelligence is getting into emotions and empathy, and will be just like thinking like us, faster, better. Why would it be so? And another stream of thought is saying that artificial intelligence will develop into something fundamentally different from human thinking. So why would artificial intelligence be just human thinking, faster, better?
In other words, can artificial intelligence also have emotion?
Right. Okay, so there's actually 3 super quick answers to that. One is, yes, good recognition, both creativity and emotion. Some people say, oh, AI will never do this. Yes, AI can do that. It's not a big deal. Why would it never go to being exactly like humans? Okay, so that's where the 2 answers come in. It would never naturally go to being exactly like humans because it's not subject to the same evolutionary pressures that we are. It's not an ape. So the only way to make it just like a human would be to set it up, and so maybe you could do that, but I don't think that that's something that society would tolerate at a wide level. So I don't think that would happen in a big way. Could somebody possibly push it that way? That's when it comes back to that ethical claim that I made before. And I think that the direction we are going right now is to try to not have too much of that. Although people, have you guys seen, I don't know if this is a future topic, the robots to replace prostitutes, I guess is the most polite way to say it.
Sorry, I don't think I quite got that. The what?
Yeah. Well, so people are trying to make more intelligent sex dolls. And they charge a lot of money for it. And it's been seen as a feminist issue because, again, it dehumanizes women. You know, I have to say, a lot of the robot
So
ethics
what's wrong
thing,
with making a man robot?
I don't know if they have done that, but that would also be...
When you get to my age, you can say that, yes.
Yeah. One of the big issues with AI ethics is the content issue. If you treat something that reminds you of a human badly, then you start treating humans badly. And so we have to be careful about that. And I really think the people who think that robots should become our children, should replace us, and that we've seen we've seen from feminism and civil rights how wrong it is to treat something not as human. I find this a very feminist issue because if what you've learned from feminism and civil rights is that a robot is as much like a white man as women and people who are not white men in general are, then you haven't really learned very much from civil rights and feminism. No. So robots are not us.
Well, you hope. Tell me, one last question. Are there any other questions around here? You don't dare, huh?
Issues. You have to face a lot of ethical issues, and I was wondering where you get support on this. Where do you find support on ethics?
We'll take another one, and then we'll come back to and look at it. Yes, over here. S'il vous plaît, madame. Oui, voilà. Merci.
Thank you very much. My name is Anna Marie from the International Committee of the Red Cross, and it's really what I wanted to ask is exactly the same question. My organization is working in zones of war where you see a lot of violence, and where the limit to violence is what the human being is able to say no, is able to distinguish between a military target and something that is not, is able to see some humanity. So I was wondering, you're talking about, well, even the conference just before was talking about drones. We're talking about drones without the control of a human being. We're talking about superhuman being. Just like, I hope that there are some studies in terms of ethics to make sure that this principle of distinction and this principle of humanity will remain.
Well, I think both of you can answer that. And take your time. It's a major problem. It also comes back to the enhanced human being, because a lot of the results of your work I can see very easily. Not only enhanced hearing, enhanced sight. Let's not even talk about superpowers, just enhanced. But that can also be, if you solve the problem of the nail in the jelly, that can also be in the brain. So I throw open, who would like to begin on the, are you working with ethical groups? Are you working as a group of scientists where you question each other on the evolution of your work?
So on a daily basis, unfortunately, we don't have ethical persons involved in our discussion. However, this is something we're very much aware of, and we do discuss among the team members and different groups and players in the project. There are at different levels, at the European level and also in the US, some structures that are getting formed in order to target those ethical issues.
More formal structures.
Correct. So what we found also is that ethics is extremely important, and this is indeed something we always have into the back of our mind, but this should not also prevent the technology to move forward, at least in the manufacturing or the design aspect. One thing that has happened over the last 10 to 30 years in neuroprosthetic is that also access to trials is a big challenge now. DBS, so deep brain stimulation, came out of one surgeon very bravely, testing it in Grenoble. And now he himself says that where he trying this today, he would not be able to do it because of regulation, because of all of this. So ethics is very important, but we also have to take into account the potential benefits.
So, Joanna, one of the problems about, and I know you're very keen on the work and the discussion you have because you have a background in psychology, human behavior, and so on, is the ethics. But there's also I would put it, the way that politics works, if you wish. Ethics is all very well. I've never noticed it to stop any kind, and all through history, all through every kind of advancement, we always had ethical problems. Until they became regulatory problems, the ethics didn't really count for much.
Well,
so how do you see it developing in your field?
Well, first I want to encourage you a little bit to know that it is developing. So I was first called into be on a government sort of panel was for the British Research Council in charge of funding AI. And so this was the robotics retreat, and that's where the EPSRC Principles of Robotics came out, which you can Google. It's one of only 2, I think now 3 national level documents on robot ethics. The South Korea's is law. The British one's just a web page, but it's getting a lot of conversation. Iceland just released one. And Chris Torres and I used to work together, so that's
all very nice, but it's still limited, so tell us.
Yeah, absolutely. So the point is that, to go back to your question, Stuart Russell, who is the founder of the Cambridge group I just mentioned, Existential Risk, keeps pointing out that what happened with chemical weapons. So we all know about sort of the failures of the physicists after they created the first nuclear bomb to stop the second and third one being dropped. So they said, okay, that was a little too late to intervene. But the chemists successfully rallied, and if you look at the Wikipedia page, it actually gives Nixon credit, but it was the chemists, chemistry professors that got that so that chemical warfare was supposed off the
But
levels.
it did nevertheless take joint political action.
It's enormous. It's enormous. You know, so was slavery. I mean, that's the level when we talk about things like, because absolutely, of course, you're right since you're from the Red Cross, but absolutely, as soon as you pull people out so that they aren't having the human experience, then they can make decisions they would never make if they were there. You would not throw a baby into a fire, but you would drop a bomb from a plane, right? So this is the kind of thing that when you displace, and this is one of the reasons that I got very involved in 2007 to start publishing heavily in this area, was this idea I saw that George Bush had of ethical robots. So his administration started funding the work on ethical robots. As soon as you say the robot is the ethical thing, then you have a problem. I want it to be very clear that the person who puts the robot out there is the one who has the ethical issue, not the machine. But this is an ongoing battle, and I just say I'm on sabbatical at the Princeton Center for Information Technology Policy, trying to figure out how to affect American policy now that I am already getting asked to talk to the British as well. So any clues, I'd love to have them.
Great. Well, that's an open invitation to everyone to get a hold of Joanna and Stéphanie. We have time for one very last question then. All right, please.
Robert Sebag, Sanofi. I will be very direct. I hate the 2 words together, artificial intelligence. For me, intelligence is a really human being, and to put artificial close intelligence for me is a big, big mistake. Sorry, I was very direct.
But you're very, that's why I call it, in general, computational intelligence, because it comes very much down to that. We haven't yet recreated the biological computational intelligence. We're still working on the computational.
Well,
we're going to take that as the last question and ask both of you to just give any closing thoughts you have. So you start with, you don't probably like artificial intelligence.
Oh, well, when I was an undergraduate, I was taught never to fight over a particular word. At the beginning of the paper, you say, here's how I'm using the word for now, and then at the end of the paper, that's over. I will not defend a term, but I will defend all the concepts that I said before. Yeah.
So last thoughts from both of you. Stéphanie.
And in my side, I mean, we look at artificial intelligence more into how we can use other intelligence to repair the body. And so here it's a slightly different perspective.
Except when you start to enhance it.
Correct, but actually before we enhance, we have to repair, and we don't know yet how to do that very well.
Okay. Any last thought from you, Joanna?
No, I thought that was my last thought. I thought that was my last thought.
That was the last thought, huh? Listen, these are 2 wonderful women scientists, and there are many more. Please give them a good hand.